Good evening, everyone. Welcome to week 2, lecture 9, the Hicksian or compensated demand function. In this lecture, we are going to derive the Hicksian or compensated demand function and the expenditure function from the consumer's expenditure minimization problem. Now, in the previous lecture, we are able to obtain or derive the Marshallian or ordinary demand function from a consumer's utility maximization problem. In this lecture, we are going to look at something different. That is the expenditure minimization problem of the consumer. So, the difference between the Marshallian or ordinary demand function and the Hicksian or compensated demand function is that the ordinary demand function is obtained from the analysis of a utility maximization problem, whilst the Hicksian or compensated demand function is obtained from the analysis of a consumer's expenditure minimization problem. So these are the two differences. These are the two differences between the two. So this is how the Hicksian demand function differs from the compensated demand function. Now, if we look at both the Hicksian demand function and the uncompensated or ordinary demand function, we notice that the Hicksian demand function is steeper than the Marshallian or ordinary demand function. Now, there is a reason to that. Why is the Hicksian demand function steeper than the Marshallian demand function? Now, the reason is that the Hicksian demand function incorporates only the substitution effect, whilst the Marshallian demand function incorporates both the substitution as well as the income effect. So this is the reason why the Hicksian demand function is steeper than the Marshallian demand function. So later on, we are going to see how the income and substitution effect are imposed or are decomposed into the Marshallian demand function. So let's go ahead and get started. Now, there is a difference between the Hicksian demand and the Marshallian or ordinary demand function. As the name suggests, the Hicksian or compensated demand function is derived or obtained as a result of what? Compensating the consumer because of what? A decline in satisfaction, decline in welfare as a result of changes in prices. So when a price changes, or let's say a price increases or decreases, so there is the income as well as the substitution effect. So we shall discuss those ones later on in the discussion. Now, if we can go back, we're looking at both the Hicksian demand as well as the uncompensated ordinary demand function. Now, the difference between these two is that The Hicksian demand function expresses what? The quantity demanded of a particular good as a function of the prices and utility, whilst the Marshallian ordinary demand function expresses the quantity demanded as a function of the prices and the income of the consumer. So this is the difference between the two. So we are looking at one that expresses quantity as a function of the prices and income, which is the Marshallian demand function, and the other expresses quantity demanded as a function of the prices and the utility derived from the consumption of the goods, which is the Hicksian demand or compensated demand function. So as a result, the Hicksian demand function is what? Is obtained from the analysis of what? An expenditure minimization problem. So here we look at the consumer tries to minimize expenditure subject to its utility constraint. Subject to its utility constraint. In other words, subject to is what? Targeted utility. So that is the expenditure minimization problem. So what we are saying here is that in an expenditure minimization problem, we are actually focusing on what? On the goal here is we try to find out what is the least amount of expenditure what is the least amount the consumer is going to spend on the two goods, assuming that he is consuming only two commodities. So what is the smallest amount of expenditure on the two goods? So that is what we seek, that is what we are trying to find. That is the goal of the expenditure minimization problem. It is different from the utility maximization problem. For the utility maximization problem, the goal is what? The goal is to find the maximum satisfaction, right? The maximum satisfaction from the consumption of the goods. Assuming that the consumer is consuming two goods, in the utility maximization problem, we are going to determine, or we're going to find the maximum amount of satisfaction derived from the consumption of the two goods. So that is what we are looking at. That is what we are looking out for in a utility maximization problem, which is not the same as the expenditure minimization problem, which tries to find out what is the minimum amount, or what is the minimum expenditure on the two goods, or what is the minimum amount the consumer is going to spend on the two goods, assuming that the consumer is consuming only two commodities. So as a result here, the compensated demand function, or the Hicksian demand function, is just expressed as what? Quantity as a function of the prices and the targeted utility, or the utility of the consumer. So as you can see here, the Hicksian demand function is denoted as HI PI U bar, which is equals to what? HI P1 up to Pn, assuming that the consumer consumes only N commodities. And then U bar. Now U bar here is the targeted utility. Now, let's look at the expenditure minimization problem. Here, let's look at the expenditure minimization problem. So, the expenditure minimization is just the complete opposite of the utility maximization, as I said earlier. It is the complete opposite of the utility maximization problem. So whereas the utility maximization problem seeks to obtain the maximum utility the consumer derives from the consumption of a set of goods given its limited income, the expenditure minimization problem seeks to obtain the least amount of expenditure on the goods given the consumer's utility. So that's the difference between the two. So in the earlier classes, the previous classes, you see us trying to obtain the optimal levels or the optimal bundles of goods that are consumed. Now remember, when we are solving a utility maximization problem, we are going to obtain the optimal values, and those optimal values are referred to as the ordinary demand function. In other words, they are referred to as the Marshallian demand function. Okay, so when you simply optimize the utility maximization problem, you try to get the optimal values, which are referred to as the Marshallian demand function. Remember, we obtain the Marshallian demand function for non-convex preferences like the Leontief preferences. We also try to obtain the Marshallian demand function from quasi-linear preferences as well. So, and we also do the one for the Cobb-Douglas utility functions. So here, we are only going to look at the Cobb-Douglas type utility function here. So, in the expenditure minimization problem, so there are three elements. You have the objective function, you have the constraint, and then the non-negativity restrictions. Now, remember, all the goods that are consumed are all positive goods. So the consumer consumes positive amount of the goods and not negative amount of the goods. So that's why when you formulate or when you try to write down the expenditure minimization problem, make sure that the objective function has what? The expenditure on the goods. Now, let's say, for example, the consumer is only consuming two commodities, let's say good 1 and good 2. So the expenditure on good 1 is the price of good 1 multiplied by the quantity of good 1 consumed. And then the expenditure on good 2 is the price of good 2 multiplied by the quantity of good 2 consumed. So, if the consumer is faced with only two commodities, then the total expenditure on those two goods is the sum of the individual expenditures on two goods. Okay? So, as a matter of fact, the objective function for an expenditure maximization problem is what? Minimize P1 x1 plus P2 x2, right? Assuming that there are only two commodities. Now, if there are n commodities, then the objective function of the expenditure minimization problem will be minimize x1 up to xn summation p1 pi xi, I ranges from 1 up to n, right? So that is if the consumer consumes n commodities. But now we are going to limit ourselves to two goods, to make the model as simple as possible. We are going to restrict the number of commodities to only two. Now the consumer is only going to consume two goods. So the objective function for that problem will be minimize x1, x2, p1, x1 plus p2, x2. So that will be the objective function. Now, if somebody asks you to write the objective function for a minimization problem, that is as simple as that. That's what you need to write. Minimize, you say you can even say min, right? Or you say minimize subscript x1, x2, p1, x1 plus p2, x2. Okay? If the commodities are x and y, then the objective function becomes minimize xy, py, px, xpx plus y py. Xpx plus y py. So that is the objective function. Okay? So now let's look at the utility maximization problem. Now I was saying that suppose somebody asks you to write the expenditure minimization problem, right? The objective function of an expenditure minimization problem. All you need to do is to say minimize x1, x2, p1, x1 plus p2, x2. Okay? That is as simple as that. That is your objective function for the expenditure minimization problem. Okay? Now, what is the objective function for a utility maximization problem? That again is very, very simple. Assuming that the consumer consumes two goods, right? And then you know the utility function as what? Let's say x1 raised to the power alpha, and then x2 raised to the power beta or beta, okay? So how do you, let's say for example, for a utility maximization problem, let's say the utility on the two goods, x1, x2 is equals to x1 to the alpha and then x2 to the beta, right? X2 to the beta. Now, how do you represent the objective function? Or how do you write the objective function for a utility maximization problem? The answer is simple. All you need to do is to say maximize this is like drinking a cup of tea, man. I'm telling you, it's like drinking a cup of tea. Maximize x1, x2. I'm telling you, I'm really good at this one. Maximize x1, x2. What? U of x1, x2, equals to what? X1 to the alpha, and then X2 to the beta. Now you see the difference here. What is the difference between the utility maximize the objective function for a utility maximization problem and the objective function for an expenditure minimization problem? It is simple. The difference is what? Now, the utility maximization problem, what? The objective function of a utility maximization problem is what? Is the utility of the consumer, right? And the objective function of what? Of an expenditure minimization problem is the budget constraint of the consumer. Have you seen? So that's the difference here. So for the expenditure minimization problem, we are going to use the budget constraint, which is P1x1 plus P2x2. Remember in the previous lectures, we said the budget constraint is what? P1x1 plus P2x2 is less than or equals to M, right? It's less than or equals to M. It should not be greater than or equals to, right? You can't live beyond your means. You cannot live beyond your means. You have to live within your budget. So your budget is given as M. So all what you spend on the goods has to be what? Restricted on that particular budget, what you have. You understand? So that's why we use the less than or equals to sign there. That let's say, for example, I'm earning $10 a week, right? And I want to spend my $10 on 2 goods. I'm not going to spend all my $10 on 2 goods. I have to save some amount, right? So in that particular case, probably I would say I'll spend like $8, right? So if I spend $8, so it means that my expenditure on the 2 goods is less than what I earn per week, right? So this is the reason why we normally put less than or equals to sign there. The less than or equal the less than or equals to sign means that the expenditure on the goods is either less than your budget or your weekly budget, or maybe your monthly income, or it is just equals to your monthly income. That means you don't have any savings, right? So if you earn $10 a week, decide to spend all that $10, you decide to blow that $10, and you're not going to have anything to save. Okay, so in that particular case, the expenditure on the goods will be what? Equals to the income. That is your weekly income, or maybe your monthly income, or maybe your bi-weekly income. Okay, so that is the idea here. So we are saying that in the expenditure minimization problem, we are using the budget constraint as the objective function, whilst in the utility maximization problem, we are using the utility of the consumer as the objective function. So that is self-explanatory. That is very simple to understand. So if somebody asks you to write the objective function for a utility maximization problem, you should be able to do that. All you need to say is maximize. Don't say minimize, right? Utility maximization, you don't minimize there. You don't minimize your utility. That one is common sense. Do you minimize your utility? You want to get the maximum satisfaction. from anything that you consume. You want to get the best out of everything that you consume. You don't want to get the least out of everything that you consume. No. So as a rational consumer, you always want to get the best. So that means you want to maximize. You get the point I'm making? You maximize. So when I say write down the objective function, please don't go and say minimize utility. Please don't do that. Please don't do that. You don't say minimize utility. You need to say maximize utility equals to maybe x1, x2, or equals to xy. Okay? So that is as simple as that. That is the objective function, right? So the utility maximization uses what? The utility as the objective function. And the expenditure minimization uses what? The budget constraint as the objective function. So that is the difference between the two, okay? Don't try to mix things up. This is simple and straightforward. I don't think you guys should have any problems with this. I don't think you should have any problems with this. These ones are so simple and straightforward. And I think I'm trying to make things as simple as possible so that everybody will be able to understand. You should be able to understand this one. This is not complex. This is simple. And I want you guys to know this. Please, please, please make sure you practice this one. I'm going to solve some problems here, and I want you to follow them. I want you to go over them. Make sure you go over them. Make sure you are able to solve them. Now, do not just read or maybe look at all my exercises, all my examples, and try to do something yourself. Try to take price theory and application, or you can take the other book by Ben Sanko. You can try to solve some of those problems. Try to write the objective functions, for every utility function that you see, try to write the objective function, right? For both the expenditure as well as the utility maximization problem. Try to do that, because that will help you. If you just try to look at somebody, solving it, you will never know it. I'm telling you, you will never know how to do it. Even me, when I was in college, I try to do things myself. I try to do things myself. I go out of my way to do things myself. So that's why that's the main reason why I know what I'm saying. I know what I'm saying. Okay. So, and I'll be able to impart the knowledge to you. So I expect you guys also to be able to impart the knowledge to others that are coming after you. Okay. So let's continue. Now, let's look at the benefits. What are we going to get from this expenditure minimization problem? There are 4 things. I tried to develop 4 things here, right? Now, well, in some textbook they just give us like 3, but I tried to add 1 more, right? So the first one is the first benefit that we're going to get from here is what? The analysis of the effect of a change in prices of the goods given the utility of the consumer. So here I told you earlier that we're going to talk about the income as well as the substitution effect, right? So when there is a price change, now you actually see the budget line either rotating inwards or maybe outwards. Remember, we did prices and the gains from trade, right? You saw the complete rotation of those prices, the relative prices, price line, right? So that's the same thing here. When the price changes, for example, let's say the price falls. So if the price falls, what's going to happen? The budget line is going to rotate outwards, right? And then when it increases, when the price increases, it's going to rotate inwards. Okay, so we're going to see that one when we deal with the substitution and income effect. So as a matter of fact here, so the first benefit we're going to obtain here from this particular problem is the analysis of the effect of a change in prices of the goods given the utility of the consumer. The next benefit here is decomposing the effect of a price change into both the substitution and the income effect on the ordinary demand function. So that's what I said earlier. Now we are going to decompose the effect of a price change, the effect of a price fall, the effect of a price increase, right, into both the substitution as well as the income effect on the ordinary demand function. Now remember, when we say ordinary demand function, we are referring to the Marshallian demand function. We are referring to the uncompensated demand function, right? So we have the uncompensated demand function. We are going to be using those terms interchangeably, okay? So if you hear somebody saying Marshallian demand function, it's the same as the ordinary demand function. It's the same as the uncompensated demand function, okay? So they are all the same, okay? So the third benefits we're going to derive from this is it will help to show how the consumer is compensated for a change in welfare because what? Of price changes. Now when the price increases, what do you expect? Consumers' welfare is going to decline. And when it declines, what happens? Is going to be compensated. So that's how this Hicksian demand came about. That's how this Hicksian demand. The Hicksian demand, which is steeper than the Marshallian demand. Now, I told you earlier before the lectures, I told you the reason why the Hicksian demand is steeper than the Marshallian demand is because the Hicksian demand incorporates only the substitution effect of a price change, whilst the Marshallian demand or the uncompensated demand incorporates both the income and the substitution effects. The Marshallian demand or the ordinary demand function incorporates both the income and the substitution effect of a price change. So that is why it is less steep than the relative to the Hicksian demand. So the reason why the Hicksian demand curve is steeper than the Marshallian demand curve is because it only has one effect, which is the substitution effect of a price change, whilst the Marshallian demand or ordinary demand function has both the income as well as the substitution effect of a price change. Okay, so you know when the price increases, welfare of the consumer is going to fall, and because the welfare of the consumer is going to fall, we expect that consumer to be compensated. Okay, so that's how the Hicksian demand came about. When we say Hicksian or compensated demand, that's how it came about. Okay. Now, the fourth one is it helps to compare the relative slopes, ordinary as well as the compensated demand function. Now, we're going to be looking at the relative slopes of those two curves, and then we see how the income and substitution effect of a price change affects the slopes of those two curves. So let's go on. Now, let's try to look at the expenditure minimization problem. Now, how do we write that one? It is simple. So all we need to do here is what? We say minimize x1 up to xn, assuming that the consumer consume n commodities. Summation pi xi I equals to 1 up to n, subject to the utility of ux1 to xn greater than or equals to U bar. Remember, now that is the constraint of the consumer in an expenditure minimization problem. That is the constraint. We are using what? The utility as a constraint, right? So as I said earlier, the utility here and the expenditure minimization is the constraint, not the objective function, as in the case of the utility maximization problem, right? So this is the complete opposite of the utility maximization problem. So if somebody asks you to do this, you have to make sure or write the expenditure minimization problem for the consumer. You have to make sure it has what? An objective function, right? What is the objective? To get the minimum expenditure on the goods, right? That is the objective, right? And then, but you are constrained by what? You are constrained by your targeted utility. Given utility, that is the utility that I want to achieve, right? So the consumer is constrained there. You understand? So that will be the constraint here. And then you also have the third element, which is referred to as the non-negativity restrictions. Now, you don't expect the consumer to consume negative amount of the good. I don't know if you have ever consumed negative amount of the good, but I don't think so. Except if you are not human, right? If you are not human, maybe you consume negative amount of the goods. But I don't see anybody who's going to consume negative amount of a good. We are all going to consume positive amount of good, maybe like say 5 loaves of bread, 10 loaves of bread. It's not negative 10 loaves of bread, it's 5 loaves of bread, maybe 2 cups of water or a bottle of lemonade, something like that. Okay, it is not minus maybe 2 bottles of lemonade. So that's what we have here. That all the goods that we consume, they are all positive amount. They can never be negative amounts. Okay, so that is the problem there. Now, so for this particular model, we have sets of assumptions here that we are going to look at here, right? Now, this model is based on the assumption that preferences of the consumer are what? Transitive as well as complete. And then indifference curves are well behaved. That is, they are monotonic. They are monotonic. So we assume complete monotonicity here. That all indifference curves are well behaved. That is to say, they slope downwards from left to right. They are not concave to the origin, they are convex to the origin. Okay? And then we also assume convexity. Now, if we don't have convexity, now why do we need convexity? Why do we need convexity? The answer is simple. The reason why we need convexity of the indifference curve is because if we don't have convexity, then we are not going to get a tangency condition. We are not going to get an equilibrium condition. Remember, in the utility maximization problem, we said the tangency condition or the equilibrium of the consumer is reached at a point where the indifference curve is tangential to the budget line, right? Where the indifference curve is tangential to the budget line. So at the point where the indifference curve is tangential to the budget line, in other words, where the budget line touches the indifference curve, at a particular point. At that point, the marginal utility per dollar spent on each good is equal. That is to say, if the consumer is consuming 2 commodities, then the marginal utility per dollar spent on the first good, good 1, is equal to the marginal utility per dollar spent on good 2. You understand? In other words, MU1 over P1 is equals to MU2 over P2. So that is the marginal utility, the satisfaction, the extra satisfaction that the consumer derives per dollar, per every dollar that is spent on the good, on each good, must be the same across all the goods. It must be the same across all the goods. Understand? The marginal utility per dollar spent on the good must be the same across all the goods. So that is the tangency condition. And that occurs if the convexity assumption is fulfilled. If that particular assumption collapses, then we can't get a tangency condition. We can't get an equilibrium condition. And so we will not be able to obtain the optimal values. We will not be able to obtain the Marshallian demand curve or the compensated or uncompensated demand curve. So this is basically the reason why we need to have that convexity of the indifference curve, right? This is the main reason why we want that one. And why do we need monotonicity? It's because we just want to make sure all indifference curves are well behaved. We don't have a situation where the indifference curves are concave to the origin when they are not supposed to be, you know? So, you know that the higher the indifference curve, the greater the amount of satisfaction the consumer derives from the consumption of the good, right? So that's how that's what we're gonna do here. We're gonna be doing here. So what is going to happen now here is that from this expenditure minimization problem, we are going to obtain the optimal solution to this problem. Now remember, in the utility maximization problem, we obtain the optimal solution, right? And that optimal solution yields or gives the uncompensated demand function, which is the Marshallian demand function, right? Now remember, we did that for Leontief preferences. We did that for quasi-linear preferences. We also did that for Cobb-Douglas preferences, right? So we did that for all those ones, right? So, and in the expenditure minimization problem, we are going to do the same thing. You can even have Leontief preferences as well as Cobb-Douglas type preferences, right? So, well, to make matters simple, we are going to just look at the Cobb-Douglas type preferences here, right? So, now, the optimal value obtained here is denoted as what? HIPI U bar. Now, remember, I told you U bar there is targeted utility, given the utility of the consumer. That one is given. It becomes what? Exogenous. It is given, it becomes exogenous. So we have HIPI U bar is equals to that. And I told you the compensated demand function expresses the quantity demanded as a function of the prices and the targeted utility. So assuming that this particular consumer consume n commodities, then the compensated demand function becomes hi p1 up to pn and then u bar. Now u bar there is the targeted utility or the target utility. Okay, so I hope you guys are able to understand this one, and I think from this explanation, I think most of you guys will be able to write an expenditure minimization problem as well as um, a utility maximization problem. You should be able to write the objective functions for those ones, right? Okay, let's continue. Now, the optimal expenditure or the minimum amount of money spent, money that the consumer spend on the goods to achieve his or her targeted utility is referred to as the expenditure function, right? So we try to obtain the optimal values, which are referred to as the Hicksian, and then substitute those values into what? Into the objective function. You substitute them into the objective function to get the what? The expenditure function. Get the point I'm making? Now you see everything here is opposite. Now how do we get the expenditure function here? We take all the optimal values, which are the Hicksian demand functions, and then substitute them into the objective function of the expenditure minimization problem. Whereas in the case of the utility maximization problem, we try to obtain all the optimal values, and those optimal values are referred to as the Marshallian, uncompensated, or ordinary demand function. We substitute them into not the objective function, but to what? But we substitute those values into a constraint. You see, the utility maximization is using the constraint, and here we are using the objective function, okay, to obtain the expenditure function. And then for the utility maximization problem, if we substitute all those Marshallian demand functions or the optimal values into the constraint, which is the budget constraint, we are going to obtain the indirect utility function. The indirect utility function. Okay? We're going to obtain the indirect utility function. So let's keep going. Now let's try to keep matters simple here. I know some of you, when you saw those Greek letters and then you saw that particular model, some of you are scared. But I want to allay all your fears. I'm trying to make things as easy as possible here. Now, let's look at this case here. And even the layman will be able to solve this one. So let's take, for example, we have a situation where a consumer consumes only two goods, X1 and X2, right? And let's say the prices are the same for both goods. P1 equals to 2, P2 equals to 2. Now, suppose the consumer wants to achieve a utility of, say, the consumer wants to attain a utility of, say, U equals to $16. This is the utility that the consumer wants to attain. Now, it wants nothing less but that U equals to $16, right? So that is what this consumer wants to attain, right? Now, the consumer can achieve this utility, his or her goal, of spending the least amount on the two goods given the targeted utility of this by making what? The following choices. So it can either choose a bundle, the first bundle X1, X2, 5, 3, or may decide to choose X1, X2 equals to 1, 6, or maybe 6.1. Or you may decide to choose x1, x2 equals to 2.4 or x1, x2 equals to 4.2, right? That is 4 units of good 1 and then 2 units of good 2. Now, let us try to look at the combination of the goods here. And then let's obtain the expenditure on them. Now, if we look at the combination of the goods there, we notice that the expenditure on x1, x2 equals 2.4 and x1, x2 equals 4.2 will be $12, right? Now, and the expenditure on x1, x2 equals 5.3 will be $16, right? Will be $16. And the expenditure for either x1, x2 equals 1.6 will be $14. Now, looking at these two expenditures here, we realize that the expenditure on the bundle x1, x2 equals 4.2 and x1, x2 equals 2.4 will be the smallest, right? That expenditure is the smallest. Because that expenditure is the smallest, that is what the consumer is going to choose, right? So he's going to choose that one. X1, x2 equals to 4.2, right? Now, let's take, for example, you have maybe differences in prices. Prices decide to change. And then how will this affect your expenditure on the two goods? Certainly, your expenditure on the two goods will be affected. But it depends also on maybe the type of goods that the individual prefers most or prefers less, right? So now, let's look at, let's try to obtain the Hicksian demand function, optimal value from the expenditure minimization problem. Now, what I'm going to do here is I'm going to give you like a simple example here. So, and then I will try to walk you through the problem to see how we obtain the Hicksian demand function. Now, I don't want you guys to use the Lagrange multiplier. I may use the Lagrange multiplier for those who are so sophisticated, for those who are well grounded in calculus. So for those who are just beginners, so let's just use the simple method. And what is that method? That is the equilibrium of the consumer or the tangency condition, point where the marginal rate of substitution is equals to the input prices. It's equals to the relative prices of the two goods. It's equals to the relative prices. Okay, so that is what we're going to do here. So what we're going to do here, we're going to use that particular condition, the tangency condition, to obtain the optimal values of x1, of x and y. Okay. Now let's consider this utility function, u of xy equals xy. Now clearly, when we look at this utility function, it's a Cobb-Douglas type utility function. It's a Cobb-Douglas type utility function where the budget share is just equals to 1 plus 1, which is equals to 2. Okay? Sometimes the budget share is equals to 1 if you sum them together. Sometimes if you have a situation like this, it's equals to 2. That is 1 plus 1. So u of xy equals xy. Now that is the utility of the consumer. Now suppose the price of good x is px dollar and the price of good y is py dollar. Now what I want you guys to do is to write the utility maximization problem of the consumer if his income is $M. Now remember here, the income of the consumer is given as $M. Now, whatever the consumer does, however it tries to maximize its utility or satisfaction, but it always have to be mindful of his limited income. It's restricted by the amount of money he or she has, right? So that's why we say that is the constraint, right? So when you have a situation like that, and then somebody asks you to write the utility maximization problem of the consumer if his income is $M. Now, his income is $M. So what we need to do here is we need to have three elements here. So for all optimization problem, there are three basic elements. What are they? You have one, the objective function, then two, you have the constraint, and then three, you have the non-negativity restrictions. So these three elements are what make up the optimization problem of the consumer, right? These three elements, the objective function, the constraints, as well as the non-negativity restrictions, which says that we only consume positive amount of the good. So if you are required to write either the expenditure minimization problem or the utility maximization problem, you need to incorporate all those three elements. In other words, you need to write down all those three elements. Okay, so all those three elements constitutes the optimization problem. Okay, so now this question says we should do that. We should try to write this utility maximization problem. Let's go ahead and try to solve this. And again, it asks us to obtain the Marshallian ordinary demand function. Remember, I told you the Marshallian demand function is just the optimal values of the utility maximization problem. That gives us the Marshallian demand function. Okay. Then you are also going to write the expenditure minimization problem of the consumer. And then you obtain the Hicksian demand function from the expenditure minimization problem for both goods. So then what is the corresponding expenditure function? So now let's continue here. So what we do here is we are going to obtain we are going to write the utility maximization problem of this consumer. Now I told you earlier that we have three elements. We have the objective function, we have the constraint, and then we have the non-negativity restriction. So these three elements must be incorporated, must be in the problem. If you don't have these three elements, then that's not a complete problem, okay? Now, how do you write this problem? It is simple. Already they gave you the utility, which is xy. All you need to say is max xy u of xy equals xy. That is your objective function, full point, full grade, right? You get the complete points, you get the credits for writing just that, okay? And then subject to what? Now remember, if you are consuming two goods, we are assuming that this consumer is only consuming two goods, and so the sum of the expenditure on the goods must be equals to less than or equals to the income or his budget. It cannot spend beyond his budget. So that is why you see that the less than or equals to sign there. Okay. So we have expenditure on X plus expenditure on Y is less than or equals to the income. Okay. And then XY is non-negative. That is xy is greater than or equals to 0. So that is the non-negativity restriction. So once you do that, you have solved the problem. So the first question is answered. 100% complete. Now, how do we obtain the ordinary demand function and the Marshallian demand function? Now, for those of you who are well grounded in calculus, you may use the Lagrange multiplier. Use the Lagrangian function, try to get the Lagrangian function. And do you all know what the Lagrangian multiplier is in a utility maximization problem? Do you all know what the Lagrange multiplier is? It is just the marginal utility of income, right? It's called the marginal utility of income. So that is what we're going to use there. Use the Lagrange multiplier for those who are well grounded in calculus. If you are not well grounded in calculus, then please use the basic method. Use the simple method that I'm going to use. Okay? Use that simple method. If you know you are very weak in calculus, you cannot obtain derivatives very well, just use the basic example, okay? Use the simple method, you're going to get the same results, right? But if you are for sophistication, then go ahead and use the Lagrange multiplier. Okay, so to obtain this one, the first thing we need to do, now if you use a simple method, just try to get the tangency condition or the equivalent condition of the consumer. We all know what that one is, right? We say the marginal rate of substitution, right, of x for y is equal to the ratio of the relative prices, right? Is equal to the ratio of the relative prices. That is to say, the marginal utility, per dollar spent on the good must be the same across all commodities. Okay, so that is the tangency condition. So we are going to use that condition to obtain the Marshallian demand function. If you are able to know that condition, then you have solved the problem. So what is that condition? Mux over Muy equals Px over Py. Right? Now, if you have a utility function given as u of x, y equals xy. So how do you obtain the marginal utility here? Now, to obtain the marginal utility here, the marginal utility of x, we simply differentiate the utility function with respect to x. That is the u, the x, and then the u dx is mux. That mux equals to y. Now, if you have utility xy equals to xy, you want to find the derivative of that. Now remember, this is what? Partial derivatives, right? We are going to hold one of the variable constant. In this case, it is what? It is y. We are going to hold y constant. Now y is L constant. And now we're going to differentiate the utility function with respect to x, right? Now, if we differentiate that one, remember, if you have y equals what? X to the n, the y dx, the y dx is what? Is n x to the n minus 1, right? So that is the derivative. It's simple. So we already have xy here, right? So x is the same as x raised to the power 1, right? So x to the power 1, take the 1, the exponent, and multiply that by x, we're going to get x. And then 1 minus 1 is what? Is 0. And then x raised to the power 0 is what? Is 1. Anything raised to the power 0, right? Anything raised to the power 0 is 1. So that's how we got this y. So you don't see x here, right? You don't see any x here. When we take the marginal utility of with x, you don't see. That's why you don't see x here. There is no x here because some of you will be asking, "Oh, where is the x?" Well, the x is gone. It is gone. It's gone in the sense that it's no more here. Now, when you differentiate this one, you hold y constant, y comes down again, and then the exponent of x is 1, and that exponent minus 1 is just 0, and then anything raised to the power 0 is 1. That's why you don't see the x here. Okay, that is basically the reason why you don't see the x here. And again, if we differentiate this with respect to y, we're not going to see the y. We're not going to see the y anymore. We're going to see the x. Okay, so let's continue. So the tangency condition here is mux over px, which is what? Y over px, right? Now we know what mux is. We have calculated that one. And so the marginal utility per dollar spent on y on x is going to be y upon x, right? It's going to be y upon px. Got it? Now, the marginal utility of good y is also what? It's x, right? That is the marginal utility of good x, of good y. That is x. And so, the marginal utility per dollar spent on good y is going to be equals to what? X over py. X, remember this muy, you have muy over there, and then muy over py is just x over py. Now, you see, if we say the tangency condition requires that mux over px equals to muy over py, right? It follows that y over px is the same as what? X over py. So if we do that, if we equate those two, we're going to have x over py over equals to y over px, right? So simple as that. This can be expressed as what? If we cross multiply, what we're going to do here, we'll take this px, multiply it by x, and then we'll take the py, we'll multiply this by y. Okay? That is what they call cross multiplication, right? We're going to have x, px times x is xpx equals to y py, right? Now we are going to, now we know what ypy is. Ypy is xpx. We just plug for ypy into the budget constraint. Remember in the utility maximization problem, the budget constraint is what? Is what? Is xpx plus ypy equals to m, right? Is xpx plus ypy equals to m, right? Remember, this is what we have, right? So in this case, what we're going to do here, because ypy is xpx, we just remove this ypy and write xpx. And then we have our plus here, we have our x, and then x. And this equals to m, right? So that's how we got this xpx, xpx. Now some of you are going to ask, oh, where is the ypy? Well, it is gone. It is gone. We don't have any ypy there anymore because we have substituted for ypy into that budget equation. Okay? So that one disappears. Right? It is not magic. It is not magic. It disappears. Now, if you know xpx plus xpx is just 2 xpx. It's just like saying a plus a is 2a, right? So x plus x px is 2x px, and this equals to m, which is the income. So if we solve this one, we're going to get the Marshallian, or the ordinary or uncompensated demand function. Remember, this is the Marshallian demand function, right? This is the Marshallian demand function. Marshallian, remember this Marshallian is the same as what? The ordinary demand function. So this one is named after what? Alfred Marshall. I don't know if you guys know that famous economist, Alfred Marshall, a British economist in the 17th century. So, sorry, the 18th century. So, this particular form or demand function is named after him. Okay, so so we have x equals to m over 2px. If we solve this one, remember, you want to find the value of x, all you need to do is to divide both sides by 2px. And if you do that, you're going to have m over 2px. Now, clearly, what does this one say? It says that if you look at this equation, it means the quantity demanded varies inversely with the price. Now you see the price in the bottom there, right? So in other words, the price is the reciprocal there, or the price is the denominator, right? So that means the quantity demanded x is expressed inversely as a function of the price. That is to say, when the price of the good increases, the demand for the good falls. So this satisfies the law of demand. Okay, so this is our Marshallian demand function. And again, if we look at that demand function, we notice that the income and the demand for the good varies directly. That is to say, as your income increases, you expect your consumption on certain goods to increase. And what are those goods? Those goods are normal goods, right? So if your income on the goods increases as your income, if the demand for the good increases as your income increases, then that particular good is referred to as a normal good. Okay? So for normal goods, usually the demand for them increases as the consumer's income increases. Right? Take for example, if you just increase, like you just experience a tremendous increase in your income, right? So what do you expect? If your income increases, you are no longer going to eat junk food. You are going to eat organic food, right? So the demand for organic food will increase. So this is what happens. When your income increases, the demand for all normal goods increases. So as a matter of fact, looking at this particular equation, you notice that this particular good is a normal good. It's a normal good in the sense that the demand for it increases as the consumer's income increases. And this particular function satisfies the law of demand, which says that as price increases, the demand for the good falls, and vice versa. Now, the Marshallian or ordinary demand function becomes x equals to a function of m over 2px. So that is your Marshallian demand function, right? That's your Marshallian demand function. Now, to derive the ordinary demand function for good y, we use the same equation. Remember, we said x px equals y py, right? Before. So that is the same thing we're going to use. But this time round, since we know what x is, we are just going to plug that into that particular equation, xpx equals to ypy. So in place of x, we are going to write m over 2px, right? So what do you observe here? Now this px and this px will cancel each other, right? When they cancel each other, you're going to have m over 2 equals to ypy. So if you solve, divide both sides by py, then you're going to get y. If you divide both sides by py, you're going to have m over 2py, which again says that the income and the quantity varies inversely. As the price and the income, and sorry, the, the quantity demanded and the price varies inversely, right? So as the price increases, the demand for the good falls and vice versa. But the income varies positively as the income. Okay. Now let's do the next question, which says, write the expenditure minimization problem. That again is simple. What we're going to do here, we are going to minimize. This time we are not going to maximize. Minimize xpx plus ypy, and then subject to what? The utility constraint xy greater than or equals to u bar. And we consume non-negative quantities of the good xy is greater than or equals to 0, which is referred to as the non-negativity restrictions. Okay. So that's the demand. That's how you obtain the demand. Remember, the demand is the optimal input, the optimal amount consumed, right? Now let's go to the D part, which says what? Obtain the compensated demand function, right? Again, we are not going to use the complex Lagrange multiplier here. Now, we are just going to set the condition. MRS equals to MEX over PY over MY equals to PX over PY, right? So that is the marginal utility per dollar spent. Each goods must be the same. And this gives us MEX over PX equals to MEY over PY. Now remember, if we equate those two, y over px equals to x over py, and then we solve, we're going to have y equals to px over pyx, right? Now what we do here, we are now going to substitute this particular variable into the constraint of the consumer. Remember, for an expenditure minimization problem, the constraint is what? Xy is greater than or equals to the utility. Okay, so now we plug for y into this, and then we solve. Plug for y there, so we solve. We take this px over pyx. We're gonna get x px over py multiplied by x, and this equals to u bar. And if we solve, x times x is x squared. We're gonna have x squared px over py equals to u bar, right? So what do you do now to get rid of px over py? You are going to multiply both sides by py over px. If you multiply the left-hand side by py over px, this one we cancel this. And then you have to do the same thing for this. You have py u equals to py u bar py over px, right? And that's equals to your x squared. So, but we don't want x squared, right? All we need to do is to raise this part to the half, each cancel, and then this whole part to the half. So then your x becomes x equals py over px u bar all raised to the r. So that is your Hicksian, right? That is your Hicksian demand. That is your Hicksian demand for good x, which is this one. Now by symmetry, xy, px, py, u bar will be px over py, u bar all raised to the r. Now to obtain the expenditure, what we do here is we just plug those Hicksian into the what? Into the objective function. And if we do that, multiply the Hicksian by the price. Remember, we add here x, yeah, but we are not going to say x, we are going to put the Hicksian demand function, right? We're going to put that one. Here we have y, we are not going to put y, we're going to put this one, this Hicksian, right? And so if we plug those ones, px, py over px, u bar to the half, plus py, px over py, u bar to the half, that gives us 2 px py u bar all raised to the power half. So that is your expenditure function. So this is your expenditure function. So I believe you guys will be able to solve this one as time progresses, and I have faith in you guys, and I know you guys are going to do well. So just keep on practicing, you're gonna make it. So I want to say